So what our division does is we have portfolios for individual protection, collective protection, and decontamination, in which we've categorized as hazard mitigation. Priorities for this year is just kind of talk about four of them. And that's respiratory protection, repellency, regeneration, and autonomy. So for respiratory protection, we've just recently embarked on designing the next generation respiratory protection for the joint forces out there. And we're looking for the general purpose mask as the main target of what we're looking at for respiratory protection. And what we're trying to solve are many of the issues that the users have with interfacing optical devices. Just, for instance, the Marine Corps adopted sights for their weapons, and wearing the mask, it's difficult to use that sight. So we're trying to look at those optical interfaces, but it's not only what exists right now, but what's going to exist in the future. For instance, there's a lot of work on heads-up displays that would integrate with the warfighter so we can see an augmented reality. You can see the terrain, and he would have particular heads-up information that was displayed in front of him, and that integrates pretty well with his just using it on his face. But when you have a protective mask on, it's difficult to use a device like that. And so we're looking at interface with not only the current devices out there, but future devices for respiratory protection. For repellency, the big issue is PFAS, which is the per and perfluoroalkyl substances, which are considered forever chemicals. And as part of the National Defense Authorization Act, DoD has been directed to look at ways to eliminate those from its inventory. And those are used a lot within chemical biological protection because they provide a layer of repellency that helps mitigate the penetration of agents and helps shed those agents from surfaces. And so we're in a process right now of looking at alternate technologies to provide this repellency without using these perfluoroalkyl substances. And one of the areas that we're looking at that is really exciting right now is the area of two-dimensional materials. These are materials that have a flat structure chemically from the molecular level, and using these a single or a few layers of these, you can achieve a lot of repellency to the surface without using fluorine or these PFAS chemicals. So that's ongoing, and most of that is in the fundamental research area. The next area is regeneration. And so what's exciting in regeneration is we've just finished 2 contracts. They're multi-year contracts that we started under OSD funding. The OSD funding was through the Rapid Innovation Fielding Program. And so we got $3 million each for these 2 contracts, and both those produced prototypes of protective garments that are non-carbon-based protection technologies that use things like metal organic frameworks or metal oxides like zirconia that can absorb the chemical agents and detoxify those agents. And we're very successful with these, and they can protect much better than we had initially anticipated. And so we're getting much better performance than we started out with on our original objective. So it allows us on our next phase to start tuning this protection so we can optimize between protection and the thermal burden and that the users have when they wear these garments. So we're going into the next phase starting this year. We're reaching out to industry to take us to the next level through a other transactional authority, an OTA process, to bring on multiple performers to get to the next generation of these materials and next generation of these garments that we can transition over into the Uniform Integrated Protective Ensemble program that JPO has. So the next area I want to talk about is autonomy, and autonomy is really exciting because joint services are exploring ways that they can use autonomous systems, both ground and aerial vehicles, in order to fight future wars. And so the Army's done quite a bit of investment into autonomous ground systems. And they have this program called the SMET program. The SMET program is a small platform that's designed as a equipment carrier that will follow units around, light infantry units around carrying their equipment. And these vehicles also have been given other functions, such as being assault vehicles, put weapon systems on them. And they're looking at increasing the level of autonomy of these systems so they can move back and forth between units, between following routes without being monitored every second of that route. And so we're using these platforms to put a robotic arm on that, along with decontaminants, and integrating that with an ability to use what is a agent disclosure spray and look at that optically and turn that into a digital mapping of where the agent is, and then using the robotic arm to go and decontaminate those specific spots in the vehicle. And so the idea will be that once a unit becomes contaminated, rather than moving to a single point on the battlefield to go through a decontamination station where they're can be quite vulnerable coming together and congregating at a single point, these vehicles can move out to where the units are and rapidly decontaminate their equipment and move on to the next unit. And so those are 4 areas that we're very excited about. Oftentimes with our funding and our technical maturity, basic research, BA1 funding, most of that goes out to universities, and we're putting out topics every year. And this year, going out on the street, we're looking at ways to engage artificial intelligence to advise the design of new materials that absorb and destroy chemical agents. So for the past 100 years, we've been using carbon as our major material we use for protection, both in filters and in protective garments. And we're looking at alternatives that not only absorb the agents, but can absorb and destroy the agents. And that way it regenerates the use of that. And use of artificial intelligence has been used as a means of designing materials. So we're looking at patterns in the design of these materials at the molecular level. And what about that? What patterns exist that artificial intelligence can identify and help us come up with better designs of those molecules to get to our objectives of uptake and destruction of chemical agents. At the applied research level, BA2 funding, most of that work is being done at the DoD laboratories, such as DevCom Chemical Biological Center and DevCom Soldier Center. Also, we have some work done at Naval Surface Warfare Center at Dahlgren, and as well as ERDC, Engineer Research and Development Center. So they're putting those initial concepts together, and that work is ongoing. And where I'm seeing is a lot of opportunity is as we move those concepts and develop specifically what we're after, we usually bring in an industrial partner to transition that work to an industrial partner that can further develop that, and that way it's ready to move into a program of record when the JPEO goes out for a solicitation. So specifically in that area on the regenerated materials and suits, as I said, we just came off of 2 developmental contracts. We're going right now into a request for prototype proposals through an OTA to go to the next generation of those suits. So that's an opportunity. For respiratory protection, a lot of that work right now is being done over at DevCom Chemical Biological Center, but we're anticipating in about a year, we're going to go out to some industrial partners and put them in the lead of that process to go through this similar OTA approach to bring in some teams to develop next generation respiratory protection. As with discoveries that we're finding right now in repellency, we're trying to come up with industrial partners once those discoveries are made to produce and scale that process up. I think the work that we're doing is very exciting. We have a lot of opportunities, especially with the foundation looking at new materials and then taking these new materials and scaling them up to look at all these applications that we're developing and transitioning to acquisition programs. So it's an exciting time to work in this area. And I think we're going to be able to do a lot to support the joint services.